In this video, we're going to look at the connection between polynomial graphs, division, and imaginary or complex solutions. So, consider the polynomial with the equation p of x equals x cubed plus 3x squared plus x minus 5 and the graph shown below. Identify the degree of the polynomial. So hopefully you remember that in standard form, which is what I have for p of x, your degree is your largest exponent. How many real solutions are there and why? Hopefully you remember also that a real solution is an x-intercept. So there is one real solution because there is one x-intercept. Part C, how many imaginary or complex solutions must there be and why? So your total number of solutions should equal the degree. And I have one real, so there are two imaginary or complex roots. And we have to explain why, so I'm just going to type my answer. Make this a little bit smaller so you guys can see. So the total number of solutions is equal to the degree, which is 3. And there is one real solution, so there must be two imaginary solutions left over. From the graph, what appears to be one solution to the equation? So if I'm looking at the graph, I'm identifying an x-intercept as a real solution. So my real solution is x equals 1. What is one factor of the cubic expression? So remember, a factor has to be an x plus or an x minus. So a 0 is x equals a number, a factor is x minus a number, or x plus a number. Find the other factors. So in order to find the other factors, we are going to divide. So I'm going to take my cubic expression, x cubed plus 3x squared plus x minus 5, and I'm going to divide it by the factor of x minus 1. When I divide, I should get no remainder because I know that it's a factor because I know that it has a real solution at x equals 1. So remember, for factoring, you have two methods. You have the box method or tabular method, and you have synthetic division. I'm going to use synthetic division. So for synthetic division, 1 goes on the shelf. I have 1, 3, 1, and negative 5 as my coefficients. We bring down the first, and then we multiply. 1 times 1 is 1, and then we add. 3 plus 1 is 4. 4 times 1 is 4, then we add. 1 plus 4 is 5. 5 times 1 is 5, then we add. Negative 5 plus 5 is 0, which is good because I should have no remainder. So remember, when I divide, my answer now is x squared plus 4x plus 5. Part G wants us to write p of x in factored form. So right now, I have it in standard form, or the original question gave it in standard form. It gave it as p of x equals x cubed plus 3x squared plus x minus 5. This is standard form because it was as a list in order of exponents from biggest to smallest. In factored form, I'm going to take my one factor, which I found in part E, which was x minus 1, and I'm going to take the answer from division, x squared plus 4x plus 5, and that's my other piece of factored form. Remember, factored form just means parentheses being multiplied by each other. And then lastly, part H says what are all of the solutions, both real and imaginary, for p of x equals 0. So real, I already know it's x equals 1, and imaginary, I know I should have 2. But I need to find those 2. So when we are solving, we can factor or we can use the quadratic formula. Because I know my roots are imaginary, I'm not going to be able to factor. Because when we factor, we get real numbers. I never get i's when I factor. So in order to find the alternative solution, remember, here's my factored form. I have the x equals 1, which we already found. Here I'm going to use the quadratic formula. So I have a equals 1, b equals 4, and c equals 5. Remember, you do not need to memorize the quadratic formula. It is given to you on tests, quizzes, final exam, regents, midterm, things like that. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to set up my parentheses. So all I need to do then is substitute. And I'm going to go ahead and plug in the a, b, and c that I found or identified before. Remember that what's underneath the radical is the only part that I use the calculator for. So I have x equals negative 4 plus or minus, I'll use the calculator in a second, and my denominator is 2. So on the home screen, not the radical, everything else. Parentheses 4, close my parentheses squared, minus 4, open parentheses 1, close it, open 5. I get negative 4. So I have negative 4 under the radical. Negative 4 can simplify to be 2i. 4 is a perfect square. The fact that it's negative allows me to put the I next to it. If you don't know that or you don't remember it, square root it right in your calculator. 2i. So we have negative 4 plus or minus 2i over 2. And then remember, your last step, you can divide everything by a common factor if there is one. So they can all get divided by 2. So I have x equals negative 2 plus or minus I or 1i, your choice. Remember that that's really two solutions. It's 1 plus and 1 minus. So it's a positive and a negative. So all of my answers together, I have 1, which is the real solution. I have negative 2 plus I, and I have negative 2 minus I. Those are my 3 solutions for the polynomial p of x.